And so let's say I tell you the sine ratio for an angle is 0.7314. What angle has a sine ratio of 0.7314? And the way that you would do this, and it has to be done on a calculator, is the following. You can solve for your unknown angles by taking what's called the inverse trig ratios. And the inverse trig ratios are located along the same buttons as the sine, cosine, and tangent, except instead of using second function, you're going to use the green diamond, and you get what's called the inverse. The inverse looks like this, sine to the power of -1. And you just take whatever the ratio is given. If you enter this in your calculator, it will tell you what the angle is. Okay, so in this particular case, if I take green diamond y to get the inverse sine function, and then enter 0.7314, close it off, and hit enter, it's going to tell me my angle measure. I will usually have you guys round these to the nearest whole degree, sometimes to the nearest tenth. But in this case, to the nearest whole degree, what would our angle be? 47. Okay, and you can confirm this. Let's take the sine of 47 and see. Is the sine of 47 equal to 0.7314? Yes. So it confirms that. Okay, so you may be asked to find the angle measure. Finding a missing angle involves an inverse trig ratio. So if I tell you that the cosine of an angle is 0.8746, tell me what the angle would be. You're going to use the inverse cosine of whatever that ratio is, and you're going to solve, and you should get 29 degrees. Okay. Again, if you're using your calculator, green diamond, inverse cosine, enter your decimal ratio, 0.8746, and you should get 29.00, again, rounding to the nearest whole degree, you get 29 degrees. Okay. And so what about the tangent? Let's say I give you a problem where the tangent of an angle is given as 3.0777. And what angle would this represent? Okay, good. Questions on that? Again, it's straightforward as long as you're familiar with the process of how this is entered. Okay, it gets a little more complicated if I tell you the following. The sine of an angle is 4/5. Okay, what angle is that? Is the process going to be any different from what we just did? No, it's still the same. 4/5 is just another form of a decimal, right? This is your ratio. So to find an unknown angle, you're going to take the inverse trig ratio, and you just take whatever that ratio is. So if we take the inverse sine, so green diamond y, write our fraction. If we put a decimal in it, we'll get an answer that's a decimal. And so we wind up with our angle being 53.13. And I'm using two decimals here just to show what triangle am I talking about here? What triangle has a sine ratio of 4/5? Opposite hypotenuse. So you know the other adjacent side. So what would we expect this angle, this other angle, to be? Not the same. What's the total sum of these two acute angles? The complement. And so what is the complement to this angle? If you take 51.13, subtract that from 90, what should this angle up here be? 36.87, to be as specific as we can with 2 decimal places. And let's see, based on this, how can we test that? If we want to, just given what was provided for us, these two. If I called this angle right here, what ratio would I have given 4 and 5? Sine, cosine, or tangent? Cosine, right? So if we test this, the cosine of asterisk, our unknown angle, is equal to 4 over 5. So we can solve for that unknown angle by taking the inverse cosine. Does this confirm what we anticipated? Inverse cosine of 4 over 5 is equal to 36.87. So it confirms what we would have expected. Okay, so what you are going to be asked to do in a lot of these problems is you'll set up a problem, use this trig ratios to either find missing angles or to find missing sides.